Okay, kids, we're back and we're on to chapter 6, so we're making a big change here from what we were studying before. We're jumping into section 6.1 and we're moving into a unit about vibrations and waves. And today we're going to start with this by focusing in on vibrations. And now a vibration is still a type of motion. It's an object or a bunch of objects, a system of objects, uh, that is repeated. The motion goes over and over and over again over the same path. But it's just not randomly going over the same paths. It's actually quite structured, and the different parts of the motions always have equal time intervals. So that's what we want to look at. Vibrations. What does it mean? What types of vibrations are there as an object goes over and over again through the same path with equal amounts of time going by over that same path. And we're going to take a deeper look at this. So the first type of vibration that we're going to talk about is technically known as transverse vibration. Transverse, the trans part means across. So you've got an object that's repeated motion along the same path, always moves across what we call the rest position, this dotted line here. So since it's always moving across the rest position, we come up with the word trans, like something that goes across the Atlantic Ocean is transatlantic. Something that moves across the continent is transcontinental. The Trans-Canada Highway, it's moving across Canada. So let's take a look at this motion here. And we can break this motion down into four parts. Here's the first part. From its highest point to the rest position, then from the rest position to the highest point on the other side is the second part. The third part is it comes back to the rest position, and the fourth part, it goes back to where it started. So we're dividing the motion, the complete path, into four parts. Each one of those parts is known as an amplitude. So here we go. First amplitude, second amplitude, third amplitude, fourth amplitude. We're back where we started. So since we're back where we started, we consider that to be one complete vibration, or technically what a scientist would call one complete cycle. All right? So that's what we have written down here. Trans means across, across the rest axis. We talked about that. Transverse vibration. So here is the rest axis. Here's like a kid on a swing or a pendulum if you want. The first amplitude from here to here, second amplitude over to here, third amplitude back to the rest axis, fourth amplitude back where we started. Where amplitude means the maximum displacement from the rest axis. How far does it get from the rest position? That's as far as it gets. That distance right here, see that distance right there? That's the amplitude. And as we said while looking at the simulation, four amplitudes are called a complete vibration, and it's known as one cycle. Now, if you remember when we were studying motion and energy and all those things, we always needed quantities, things to measure to help us understand motion. So we had quantities like time and displacement, position, velocity, acceleration, work, different types of energy, forces. We always had quantities that could be measured that helped us analyze motion. Well, similarly here, we need quantities to help us understand, measure, quantify vibrations. And we're going to start with the quantity known as period, and its symbol is big T, and it is the time required for one cycle of vibration. How much time does it take for it to go through one cycle? So there's a very easy way to figure out how to find the period of the vibration of this particular pendulum. Well, what you could do is you could measure how much time it takes to go through, I don't know, let's say 10 cycles. So you would measure 1, 2, 3, 4 amplitudes, 1 cycle. And you would do that. You would say 1 cycle, 2 cycles, 3 cycles, and so on. Let's do that. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you could, if you had a stopwatch, you could figure out, oh, it took so much time to go through 10 cycles. So you've made some measurements, and now we can use them. So let's, for the sake of argument, say, and here's a new equation for you. It's the equation for period. The equation for period equals how much time went by divided by how many cycles you measured. So let's say in that little simulation that we just went through, because I can't do it for you live, we're not in the classroom, let's just say for the sake of argument that 10 cycles, right, and each cycle is 4 amplitudes, took 11.5 seconds. So you do your dividing and you would get that the period, T, is equal to 1.15 seconds. That's how much time it takes for one complete cycle. That is known as the period of vibration. Now, there's another very important quantity we have to understand if we're going to understand vibrations, and it's called frequency, right? Do you go to the corner store frequently, right? Well, that would mean you're going to count up how many times you go to the corner store in a certain amount of time. So for vibration, it's the number of cycles per unit time. And since we're in physics class, the unit that we use for time is seconds. So here's a new equation for you. Frequency, little f, is equal to the number of cycles divided by time. Well, we're going to use the data that we had up here for period, and we get 10 cycles divided by 11.5 seconds, which gives me 0.87 per seconds. So the number's in the numerator, but the unit is in the denominator. Or you can write it 0.87 inverse seconds. Or you could write it as 0.87 cycles per second. Cycles per seconds. Or you could use the unit that everyone uses now, named after the great scientist Heinrich Hertz. All right. And instead of using all these unit symbols here, we use HZ. So it would be 0.87 hertz. You may have heard of hertz before. So 0.87 hertz, here's how you spell hertz. So the frequency is 0.87 hertz, or 0.87 cycles for every second. So it's not even a complete cycle per second. You know, a second is larger. You don't even get a complete cycle per second. You only get 0.87 of a cycle per second is what I'm trying to say. Now, the thing you got to look at here is if you look at these two equations, period, time is cycle over number of cycles, and frequency here, number of cycles over time, we've just flipped numerator and denominator. So we can say that we know the relationship between period and frequency. They are the inverse of each other. Period is the inverse or reciprocal of frequency, and frequency is the inverse or reciprocal of period. So if you take a look at the equations, we've just flipped numerator and denominator. All right, there's another type of vibration called longitudinal. Longitudinal, and it's called longitudinal because the object is moving along this line all the time. It's not like transverse when the object was moving across the line. No, it's moving along the line. And longitudinal means to move along. So if you take a look at it, it still can be considered four amplitudes. Watch. One amplitude, two amplitudes, three amplitudes, four amplitudes. So that idea is still here, that the object undergoes four amplitudes in one complete cycle of vibration. And one complete cycle of vibration is done when the object goes back to where it started. So it starts here, one amplitude, two amplitudes, three amplitudes, back to where it started, four amplitudes, one complete cycle. Except now this type of vibration is known as longitudinal. And that's what we have here. Here's the rest axis right here. The rest axis is right here. Okay. The rest position is right there. And the object will go down in this case, up, up even further, and back down to where it started. There are your four amplitudes. So four amplitudes still equals one cycle, except the motion is longitudinal vibration. It looks a little bit different. And the last type of vibration we're going to look at is this one right here, which is called torsional. There's a twist. They've wound a spring around a pole and attached it to a disc, and it moves. It moves around the rest axis. Goes one direction. Let me start it again. One direction, then the other. Back and forth, and back and forth. So this is still a vibration, but it's a twist. So this is known as torsional. And I've tried to draw it as best I can. Here's maybe another way of looking at it. Here's a spring and a mass at the end of it, and you twist the spring. And since it twists along the rest axis, it's known as torsional. We don't do a lot on this type of vibration. We spend most of our time on the first two, transverse and longitudinal. But if you spent time, you could still see that you could start to twist, and it would go one amplitude of twist, two amplitudes of twist, stops, goes back the other way, three amplitudes of twist, four amplitude a twist, and the four amplitudes would still be one cycle. So I've introduced to you the three different types of vibrations. I've introduced to you two new quantities that we need to study vibrations, period and frequency. And here's our start on the new unit, all about vibrations and waves. Have a great day. Bye-bye.